recording. All right, so welcome everybody for exam 1 for statistical methods, chapters 1, 2, and 3. Okay, as we go through, I will kind of lay out which where stuff is coming from, you know, like what chapters and things like that. It pretty much will go in order the same way that your quiz for chapter 1, 2, and 3 went. So if you got any questions, just let us know and let's get started. So question number 1 says the data were collected from a statistics class. The columns head give the variables, and each of the rows represents a number, represents a student in the class. How many variables are there? So what do you guys think? How many variables are there?
9.
You got it. Each column heading is a variable. So being male is a variable. The age is a variable. Eye color, so on and so forth. So the number that goes in this blank is 9. And these first questions, this is all coming from chapter 1, just so you know. I'll let you know when we hit chapter 2. So again, we've got this data from a statistics class. We've got our variables up at the top. So we're going to answer some questions. So it says, is the variable handedness numerical or categorical? Explain. And again, just like in your assignments, you really didn't have to type anything out. This is all multiple choice. Okay. So first things first, is handedness numerical or categorical?
Categorical.
Absolutely. Because categorical usually are like descriptions, properties, qualities. Okay. In handedness, you were either right-handed or left-handed. Okay. Numerical is exactly that. It's numbers. But just know, just because a column might have numbers in it, it could be categorical, as in the male column right here. This is categorical, even though there are numbers, because what they have done is they have put in, they basically, oh gosh, the word is slipping my mind. I'm going to have to look it up real quick. That's going to bother me. It is called where we take the data and we exchange it for numbers. Oh. Give me just a moment. Gosh darn word is slipping my head. We call that, here it is, coded. We coded it. I don't know why that word slipped my head. I think I was looking for something more technical. So they coded this where 1 represents male, 0 represents female, instead of writing out the words. So even though you might see numbers, that doesn't always mean that this is numerical. This is actually categorical. It's been coded. So you guys said that this is categorical. That narrows it down to 2 answers, B and D. So when you read this, it says it's categorical because the values are numbers. It's categorical because the values are categories. Which one is it?
B.
B. You got it. Because these are categories. Either you're right-handed or you're left-handed. One or the other. You're not both. Okay. Also, usually when they talk about numerical is all about when things are measured. So numerical values are stuff that you can measure. Like we can measure weight. Okay. We can put you on a scale and it measures you. We can measure your age and how many years have you are, on this. We can measure your college units. How many classes have you taken? Okay. So we can measure that. So question B says, is the variable shoe size numerical or categorical? And explain. So what do you think?
Numerical.
Definitely. So that narrows it down to B or C. Which one is it?
Because the values are numbers.
That's right.
B.
And it's measurable. Yeah. We can measure your foot size. So there you go. Any questions about number 2?
You said that was B?
Yes.
Okay, thank you.
No worries. And I'm writing all this information down, like as far as the answers. So you'll have an answer key. And if there's any work that needs to be done on the answer key, you will see that information as well. Okay.
Is this review posted like on Canvas?
Yes, this review is posted out there, but it's in the review site where it's posted.
All right.
So yes, there's a blank version, and then I'm working on, and I'll actually show you. So this is the worked up version. So we said B and then C, if I remember correctly. Make sure on that one. Oh, nope, B and B. My bad. B and B. So this is what I'm working with on the side. And if there's work to be shown, I'll flip over to this document camera and we'll do the workout together and show you where everything's coming from. But for most of these, like I said, in stats, it's a lot of, talking back and forth and discussion wise. Okay. So, but this answer key will be put out there for you. And like I said, I'm labeling when chapter 1 is, when chapter 2 and chapter 3. Okay. All right, question 3. So an even bigger column now. So it says the accompanying data were collected from a statistics class. The column heads give the variable. Each row represents a student. Suppose you decide to code handedness using right-handed as the label for the column. How many ones and how many zeros would there be?
Will be 3 ones, 3, 4, 5, and 6 zeros.
Okay. So I'm writing this down so we can talk about it real quick, even though, you're not really going to show this work, but I want to let you guys see exactly where Miriam just got all that information from. So, losing where I was at. This is that column. And it said we wanted to do this according to right-handedness. Okay? So when they say right-handed is your column, that means anybody that's right-handed is a 1. Anybody that's not right-handed is a 0. So left became 0, R became 1, left became 0, right became 1, then we got 4 more zeros, and then a 1 at the bottom. So she's absolutely correct when there are 3 ones and 6 zeros. Does that make sense?
Yes.
Yes.
Okay. So we coded it. That word that that word that was elusive to me earlier. So there would be the number 3 and 1s and 6 and zeros. Okay. Moving on. And last but not least, because this should be the last question, maybe. Nope. Still a couple more questions. Still in chapter 1. All right. So right here, it says researchers conducted a study on the brain as measured in pixels in a magnetic or MRI machine. Okay. The numbers are in hundreds of thousands of pixels. Okay. That would be this number that's right here in the brain. So they want to know, based off of this information, is this stacked or unstacked? What do you think? Stacked or unstacked? Do you guys remember what stacked and unstacked means?
Trying to remember. Yeah, I've seen it somewhere.
Okay.
It's
Stacked.
unstacked, right?
Say it again.
Unstacked
It is not unstacked. This is
It's
actually stacked data.
data, yeah.
Stacked data means that you have more than one group,
Column. Yeah. Okay.
more than one group in here. And so it's not the brains that's the problem. It's right here. In here, you have two different groups. You have females and males. So stacked data, it's like it takes two groups and put them together. Like up here, this is stacked data according to handedness. Okay? Because we have two different groups in here. We have right hands, we have left hands. That's stacked data. Because there are two different groups represented. There are two different groups represented right here, males and
And
females.
females. Yeah.
So this is stacked data. Okay? So it says explain the coding. So
One
what does
one
one
is
mean?
male. Yeah.
Okay, you got it. One is male and the 0 is?
Female.
You betcha. I'm just writing down this information. So if it seems like I'm kind of like pausing for a moment, I'm just writing. All right. And then down below, it says if you answered stacked, then choose the unstacked. Okay. If you answered unstacked, then choose the stacked. So we answered stacked. We want the unstacked. Which one down here shows unstacked?
A.
A is stacked data. We want to separate it according to the male and the female. See, it even gives you a hint right here. Then unstack the data into two columns, male and female. Does that make sense?
B.
So it's either B or C, right? We just got to
I'm
make sure we know.
confused.
Well, there are two answers here, female and male, right? So it's one of these two. We just got to make sure we know are the numbers in the correct column, okay? So we go back up. So there were 3 females with numbers. So we make sure that, yes, you are correct with the B. You see what I'm saying? You got to make sure that these 3 numbers, are they really the female numbers? And these numbers are really the male, okay? Because there are 2 of these that are unstacked, B and C. So just watch that information. So yes, you were correct because 9.4, 9.7, 9.8 are the female versions. And C, female, 9.4, 9.7, 9.8. Does that make sense?
Yes.
Okay. All right. So a little bit of math here. There's not a lot of math in this first exam. Not a lot of math. And if there is some math, we're going to let the calculator or we will let StatCrunch work it all out for us. So right here it says a statistics class is made up of 20 men and 17 women. What is the percentage of the class that is male? So how do we deal with that? Got 20 men and 17 women. This is what we know. We want to know what is the percentage of men. So how are we going to figure that out?
Could we add 20 and 17 and make that the denominator and then put 20 in the numerator and then just solve?
You got it. So you can set up a proportion. I like that you added these together because you need the total. Okay? And there are 37 people total. Because that's important for us. Because we want to compare the men to the total. So if we go into our calculator and divide that, we've got 20 divided by 37, right?
Yes.
And there's our number. What do we got to do with this now?
Convert it to a percentage.
And how do we convert it to a percentage?
Multiply by 100.
Yeah. multiply by 100.
100, yeah.
So we're going to say times 100. And that gives us
54%.
54%. But we should always go back and look at the fine print and make sure that we are going to round to the proper place. So we go back, it says round to 1 decimal place. So if you said 54, we're off. So if we go back to this is what the calculator gave us. Okay. After we took our answer times 100. I just don't want to rewrite all those decimals. So rounding to the nearest hundredth, what do we get? Sorry, not hundredth. 1 decimal.
54.1.
You got it. 54.1 is what they're looking for. Cool beans? Another way that I would do this one, the way that I would set it up in class, is I would have the 20 over the 37. And then over here, I would have the percent I'm looking for over 100, and I would solve it like a proportion. Okay? And that takes care of all this math right here in one simple problem. So this would be like a variable x, and I would cross multiply to solve. Just another way. But all ways are good ways. All right, so the next one says, a different class has 290 students, and 51.7% of them are men. How many men are in the class? So we've got 290 students. I'm just writing this information down. And 51.7% are men. We want to know how many men are there? Okay, how do we do that? Lots of ways to do this.
Could we just do how you set it up there? Set it equal to
Like this?
51 points. Yes, sir. Set it equal to that, and then just solve there.
Yeah, absolutely. So we know that there are a total of 290 because that's what went down here was our total that we had up here. But we don't know how many men, right?
Right.
And that should be equal to 51.7 all over 100 because that was my percent, and percents are out of 100. Yeah, this is exactly how I would teach it in class. It's like solving proportions. So all we do is cross multiply. So x times 100 is 100x. And 290 times 51.7, what'd you guys get for that? And don't do any rounding. We're going to need that exact number.
14,993.
14,993. Okay. And then to get x by itself, divide by 100. So x is equal to
149.93.
0.93. Okay. And then obviously in this one, it's not going to make you round to a decimal because we're talking about men. And I don't know what a 0.9 of a man would look like. That's just weird. Is it just a man without 2 fingers, without 2 toes? He's still a man, even though he's missing some digits, right? So when you do this one, I'm pretty sure it says round to the nearest whole number. So yeah, we don't have any decimals of men running around. A man's a man. A woman's a woman. Whether they have an arm, missing a leg, no head, they're still a woman. Although that would be really weird if you're missing a head. So what is it? How many men do we got?
150.
150. So there we go. All right. C. So a different class is made up of 46% women and it has 17 women in it. They want to know what is the total number of people. All right. Oh, just real quick on B, another way that you could have done this is you could have taken kind of like what you were dealing with up here. You could have taken 290 times the percentage, but remember the percentage would have to be a decimal when you multiply it. So 0.517. You could have also done that to get to this answer. It's just another way of doing it. But I always just, my rule of thumb for these three, I always just use proportions. Keep it consistent. All right, so how do we do this? What do you think? Could we just set up another proportion?
Mm-hmm.
Yeah, right? We know our percentage. How much is the percentage?
46. 46.
Yeah. And that's percentages are always over 100. Do we know the total?
No.
No. So that's X. Now this 46 is about women. So do I know how many women are in the class?
Yes.
Yeah. How much?
17.
Boom. And now all we got to do is solve. So X times 46. 46X. Yeah. 17 times 100.
1,700.
Yay. And then all we got to do now is divide by 46.
46.
X equals.
36.9.
It's just 36.9, no other decimals.
565217.
5217, right? Okay. But again, we're talking about total number of students. I don't have, 0.9 of a student walking around. Again, I don't even know what that looks like. So how many students are there total for this?
37.
Yay. 37. And just kind of going back to check, make sure that nearest whole number. And there you go. Any questions about A, B, and C? Okay, really easy. You can just do proportions the whole time through. You can do proportions the whole time through and get to that answer. Okay? Yes. Good. I'm glad you all agree. Okay. I miss being in front of students. All right. So number 6, this is actually should be, let me double check, make sure. Yeah. This is the last question from chapter 1. So 1 through 6, all chapter 1. So it says, indicate whether the following study is an observational study or a controlled experiment. All right, here's the study. A researcher is interested in the effects of music on memory. She randomly divides a group of students into 3 groups. Those who listen to quiet music, those who listen to loud music, and those who will not listen to music. After the appropriate music is played or not played, she gives all students a memory test. Okay. So first thing, is this observational or is this controlled?
Controlled.
Okay. So that means we're either B or D. Now let's read these explanations. So B says she assigns students to the control and treatment groups at random. Okay, in order to control all relevant factors aside from the effect of the music, which is essential in conducting a controlled experiment. So that's B. And D says this is a controlled experiment. She controlled for other factors prior to assigning students to control group and 2 treatment groups. This is essential to conducting a controlled experiment. So which one do you think it is, B or D?
B.
Definitely B. Because the big thing down here, it says she controlled for other factors prior to assigning. We didn't read anything about anything happening prior to this experiment. So that's the big key where right here, I knew it wasn't D. Make sense?
Yes.
All right. So number 7 starts chapter 2. Okay. So this is where we actually started diving into some of that, some of the capabilities of StatCrunch and your calculator and all that. All right. So right here, we have a histogram that shows the number of televisions in the homes of 94 community college students. And we've got some questions to answer. All right. So it says, according to the histogram, how many homes do not have televisions?
4.
Yay. You just look at the bar for 0, and it's up here at 4. Okay? I'm just writing down the letters real quick. All right. So over here, B says, how many televisions are in the homes that have the most televisions?
3.
Mm-mm.
Oh. 5.
Uh-uh.
Right? That's 6.
How many televisions are in the homes that have the most televisions? Who has the most number of televisions?
Oh, 6.
Mm-mm.
Wait, I'm confused.
I want to know how many televisions are in the home with the most. That's what they're trying to get at. Giving you a hint right now.
Oh, there was more to the graph. I didn't see that. 9.
That would so how many the home with the most televisions, how many do they have?
They have 9 televisions.
9. That's the answer. Homes that have 9 televisions have the most televisions. That's what they're at. They're not asking about the center. They're not asking about which bar has what is the typical what you were trying to tell me earlier with the 3, which I get what you were trying to tell me what is typical in houses. And what's typical in houses is the largest bar, which is 3. This is a typical house. But what they were getting at here is they wanted to know homes that have the largest number of televisions. That's 9. Does that make sense?
Yes.
The wording is really, really weird, but that's what they're trying to get at.
Okay.
All right. So how many homes have 3 televisions?
28.
Okay. Because again, you just go up to this bar right here. And so here is 26, 27. Yeah, that's definitely 28. You just read the top of the bar. All right. So now it says, how many homes have 6 or more televisions?
8.
8. So let's count it up. So right here, this is up at 5. This is up at 2. This is up at 1. So definitely 5 plus 2 plus 1 is 8. Because you look at these last 3 bars right here. 6, 8, and 9. Perfect. And now the last one says, what proportions of homes have 6 or more televisions? And it says write an integer or a simplified fraction. In other words, what they're looking for is the fraction. So how do we find that proportion?
Oops.
You guys were writing proportions just a second ago, like what we were doing with number 5, although we're not going to solve it.
So do we put like 8 over how many televisions there are?
That's right. 8 over the total. And then we have to reduce that. So if you look carefully, you don't have to count up all these bars. They tell you how many people we talked to.
94.
Yay. So this is our fraction right here, 8 over 94, but you got to reduce that. Okay, and we just let our calculator do it. Your best friend, alpha, y equals, there's your fraction key. Right there, number 1. Select it, put 8, scroll down to the bottom, 94. Enter. And there's the answer. Cool beans?
Yes.
Yay! All right, going back. So there's number 7. All right, number 8. Histogram shows the frequencies of the ages of 25 randomly selected CEOs. They want to know what is typical.
56 to 64.
56 to 64. Okay, well, let's
To 60. Sorry.
to 60. Yeah. You don't want to go to 64 because that's 2 bars. They just want to know what is the range for the tallest bar, which is this guy. And it's counting by 4s if you didn't kind of notice that. So this is 40 to 44, 44 to 48. So we want this bar that represents 56 to 60. And that answer is A, B, C, or D.
D.
Say it again.
D.
D. I thought you said B for a second. I was like, what? Yeah, because right here it says the typical age of a CEO is 56 to 60. Yay! Moving on. Okay, number 9. Again, all this is in chapter 2, and it really is going in order of the sections. So I'm not really telling you what sections they're coming from, but hopefully a lot of these problems seem familiar because they're just like the ones that you did in your assignment. All right, so it says the accompanying histogram shows the distribution of the number of siblings, brothers and sisters, for 20,000 adults surveyed in 2012. Let's answer some questions. So there's an A, B, C, D part to this. Okay, so it says describe the shape. What's it look like?
B, right skew distribution.
Boom goes the dynamite. Yeah. Because it goes up and then it peters off, and then this is where we call the tail. And the tail is what tells you the distribution. So whenever you're dealing with skewed data, wherever the tail is, that's the name of it. So the tail is on the right side, hence right skewed distribution. Okay? Skew is not about where the bulk of the data is. Skew is about where is the tail. All right? So here it now says, what is the typical number of siblings?
2 to 3.
2.
2 to 3? Yeah. I mean, and again, this is my math lab and all that stuff. I would have actually said 1 to 2 because these bars are so close. That's the typical stuff right there. But based off of what I see here, we have to choose B, 2 to 3. Does that make sense?
Yes.
Because 2 to 3 out of all of these are the highest bars. Okay, so 2 to 3. Again, though, I would have said 1 to 2. But that's just me. All right, so it says about how many people in the survey have no siblings?
About 100.
Okay, about 100. So which answer would you go with?
B.
B, 80 to 100.
Yeah, I wouldn't go with this one, even though it does have 100 in it, because this is over that.
Mm.
And obviously, we're still under 100 here. So definitely B. See, good observations. Like I said, a lot of this, there's not a lot of math on this. A lot of it is just, looking at what you know and then telling us, finding that multiple choice answer down below. So it says, what percentage of, that must be a typo up here. I am willing to bet that this is not 20,000. Well, maybe it is. Maybe this is the typo down here. Let me double check something.
Did you say the number of siblings or number of people who didn't have siblings was 80 to 100 or 100 to 120?
80 to 100.
Gotcha. Thank you.
No worries. We're on question number 9. There it is. Oh, these are percentages. All right. So let's go with 2000s adults here. And then we'll also figure this out with 20. Deanna, can you double check that? Actually. So number 9, part D, because up here we have 20,000. Down here we have 2,000. I need to know which is the number because that's going to change our percentages a lot. So I'm going to come back to 9D here in a second when Deanna tells me what the real number is. Okay. So I just want to double check that. Is that fair with you guys?
Yes.
Okay. So we're going to come back to that. All right. So number 10. Number 10. Moving on. Number 10. So it says that we have a table on the next page that shows the average lifespan for some mammals in years. All right, so here's our table. Boom, 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 boom. So we're definitely going to want to use StatCrunch on this. I can already tell. It says graph the average spans and describe the distribution. What is the typical lifespan? Identify outliers and report their lifespans. If you were to include humans in this graph, where would they be? All right, so we need StatCrunch. And in your exam, remember that you guys have that little help or that little sprocket that's over here in My Math Lab. And when you click on it, it will show you access to StatCrunch on it. Okay. So you have access to StatCrunch during the exam. So we need to go, I'm going to bring up this chart, and we need to put all these numbers into StatCrunch. So I'm going to have you guys help me out. Hopefully you got these numbers on your screen, and I'm going to go to StatCrunch and run this for us. So that way we don't all have to do it. So I'm just going to call this lifespan, since that's what we're talking about. Start getting me some numbers.
10,
Check.
25,
Cool.
20,
Okay.
12,
Keep going.
12, 20, 15, 40, 12, 35, 16, 5, 12, 7, 15, 12, and 16.
And that means we have 17 numbers. I always double check this. I'm going to go back and count up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. All right, so we match. Because if we don't have all these numbers, that's going to mess everything up for us. Okay? So when we make a histogram, because that's what they want, where do I go?
To graph.
Graph. Oops. Now where?
To histogram.
Yay. And we want to select lifespan. Make sure that you select what you want to look at. Okay. And then again, as I always say, I really just don't mess with all this stuff down here. I let it do its thing. So there's what it looks like. And then we can come over and we can look and see which picture kind of matches that. Also, if you kind of notice, it looks like their pieces are going by fives. Like each bar represents kind of like a distance of 5. So if we wanted to, we can go back and kind of mess around with that information. But where's my set crunch? There it is. Let's see here. Oh, this is actually going by 5s as well too. So we really don't have to go and mess with our information. So this is what our picture looks like. Which picture over here matches it? A, B, or C?
A.
It is A. Because this is the one that, you know, you have that nice little tall bar right there, and then there's a space and 2 more bars. That's exactly what ours looks like. Tall bar, space, and then 2 more bars. Okay? So definitely. So we know what it looks like now. Cool bean. Any questions about how we got the histogram in StatCrunch? Okay. So we know that this is A. So it says, describe the shape of this.
Right skewed.
Right skewed. Perfect. Because we have a tail over here on the right side. And again, you can see that really here. It goes up and then it just peters off and a tail. Okay. All right. So it says, what is the typical lifespan?
10 to 15.
Yeah, 10 to 15. And again, you can go into your scatter plot. Here's the tallest bar. If you just let your cursor hover over it, right there, it says lifespan 10 to 15. Okay. So we know that that answer for part C is B. And then down at the bottom, it says identify any outliers. Okay. So if we look at this, since I've kind of lost everything, do I have any outliers?
Yes.
Who?
40.
40. So whoever these two are, right?
Yeah.
So the ones that looks like from like 35 all the way up to 45. So let's go back to our chart. Who is in that range? The 40, which is the
Elephant.
elephant. Both elephants, right? So we would select A, B, C. Which one is it?
C.
C. Because they're both the elephants, the African and the Asian. All right. So now remember up here, it said humans average 75 years. So what's cool is we can go back into StatCrunch and we can add humans in real quick. 75. Whoops. Come on, write it in. 75. And then now if we go back in to edit and then compute, now we have humans in there. Okay. So let's go see what they want to know. So since we added humans, where would this point be? What happened to it?
Would be off to the right.
Yeah, it went way far off to the right.
Yeah.
So E is C. Because right here, you can see what happened. I'm losing track of where. This was all the original animals. And then when I added humans, boom, there we are. So definitely off to the right. Everyone good?
Yes.
One
All right,
more. One question, very quick.
Sure.
I missed this. I was getting something for my son. Yeah, when you put the variation, you wanna do you hit graph to get to this graph?
Uh-huh. I went to graph and then the histogram.
Histogram. Oh, okay.
Mm-hmm.
All right.
So I want to get rid of this now, delete. And now we're back to normal. Okay, moving on. All right, number 11.
Hey, Brendan, just
Hey.
don't want you to forget about question number 9. So I looked it up. It was 2,000 adults.
Like down here and up here at the top two?
Yep.
Okay, so 2,000 total. All right, cool.
Okay.
No worries. So let's go ahead and jump back to number 9 and let's finish that up then real quick since we now have confirmation that it is 2,000. So we know that no siblings is between 80 and 100, right?
Yes.
And we know that there are 2,000 adults. So they want to know the percent they're between. Okay? So in order to find that percentage that they're between, we'll take 80 divided by 2,000 and get that percentage. And then we'll take 100 divided by 2,000 and get that percentage. Does that make sense?
Yes.
Yes.
All right. So when we take 80 divided by 2,000, what do we get?
4.
4?
Yeah.
No, that's not 4.
Like 0.4.
0.4. Let's double check that. That seems high.
0.04. Sorry.
Okay. I'm like, that's a little high. Let me double check, make sure. Okay, 0.0. Yeah. Now that makes more sense. Okay. And then what's 100 divided by 2,000?
0.05.
Okay. So 0.05. So if we turn these into percents then, what's the percentage at 80?
4.
4% at 80 and
5%.
5% at 100. So these are the numbers that go into those blanks respectively. Put the 4 in the first one and the 5 in the second one. Cool?
Yes.
There we go. All right. So now let's chalk to number 11. All right. That was 10. 11. According to an organization, there are 5 leading causes of preventable death in a region. They are shown on the graph. So you got high blood pressure, tobacco use, high blood glucose, physical activity, and overweight and obesity. And all they want us to do is answer some questions. Okay. So it says, how many preventable deaths result from high blood pressure? And it says round to 1 decimal place as needed. So your best guess, what do you think?
Maybe like 7.5.
Yeah, it does kind of look halfway, right? Maybe 7.5, 7.6. I would accept either one of those answers. It actually says down below 7.6, but 7.5 is just fine. Because again, it's kind of hard to read that, without being extremely, more information given to us. So there we go, right here. Okay. All right. What about B? It says estimate how many preventable deaths from tobacco use.
It looks like 5.
5.
Yeah, right. Maybe 5.0, maybe 4.9. But I believe down below it said 5.0. It does say 1 decimal place, so I include the 0.0 just to appease the My Math Lab. I don't know if it will count you. Yeah, it says 5.0. I don't know if it will count you wrong if you just put 5. So I just be cautious of that. So if the decimal is a 0, just go ahead and put it in. Why risk it? All right. So C says, does this graph support the theory that the greatest risk of preventable death is overweight and obesity?
No.
No. So there's part of the answer to C. So you will say no. And then it says the graph does or does not.
Does not.
Does not is the other answer. There you go. And then part D, oh, sorry, still even more. There's one more answer to part C. So it does not support the theory that the greatest risk of preventable death comes from overweight and obesity, because overweight and obesity blank do not cause or cause the greatest number of deaths.
Do not cause.
There you go. Do not cause. Cool. So just make sure that you watch out for those three answers. There'll be drop-down menus in that question on the exam, just so you know. And the last one is, this is a bar chart with a special name because they are in descending order. Which one is it? Perot chart, histogram, dot plot, stem plot?
A.
It is A. Yeah. Perot chart is a bar chart, just like what we have up here, but it is in descending order. They start from the highest bar and work its way down. Okay. So this is definitely a Perot chart. All right. So number 12, moving on. So it says the table gives information on majors at a certain college. Select an appropriate graph for the distribution. So they want to know which one of these graphs right here is good for this information. So some things to make note of. Make sure that you watch out for the percentages. Make sure that they match on your graph down below. So we got humanities, social science, math and science, interdisciplinary. It looks like your social science should be the largest graph. Interdisciplinary should be your smallest or largest bar for social science. Interdisciplinary, your smallest bar. So obviously you can tell this is not it. This is not it either because we need social science to be the largest, right? So it's either A or B. Which one is it?
A.
It's got to be A, because here you can see social science is the largest, intermediate is the smallest. Okay, it's just a little bit below that guy. And if you look at all the percentages, they do match what's going on up above. So we definitely know that A is the answer to part A on number 12. All right, so now with that information, which would you choose for also being able to show that? So right now, what are other ways that we can show this? Select all. So how else can we show this information? And again, this is all categorical information. That's where this is coming from. How can we display categorical variables?
Histogram?
No.
No.
This is not a histogram. Remember, histogram bars would touch because it's like a number line. Does that make sense? In a histogram, your x-axis is all numbers. These are not numbers. So not a histogram. Histograms are for numerical categories, and these are not numerical. Does that make sense?
Yes.
Okay. Just want to make sure that I get that cleared up. How else? What else could we do?
Can we use a pie chart for this?
You absolutely can. So pie chart is another way to display this. Okay? And there's one more on here.
Pareto chart?
Yep. You got it. B and C are the ones that you need to select. Because for categorical data, you have three options. A bar chart, which is what this is. This is a bar graph. their Perot chart, which would just take this bar graph and put it in order, like what you saw right here, from largest to smallest. Or the pie graph. Those are the three we use for categorical. Everybody else, numerical. All right. And C. C says, which of the following is the best description? The mode is math and science. The mode is humanities. The mode is social science. The mode is interdisciplinary.
Social science.
You got it, because that's the tallest bar. Okay. So right here, the accompanying graph shows the distribution of data on whether houses in a neighborhood have a garage, which is indicated by 1, or do not have a garage, which is indicated by 0. Is this a bar graph or a histogram?
Histogram.
Say it again.
Histogram.
Histogram. And then I had someone say bar graph. We're kind of split.
Histogram, the bars are attached to each other.
Mm-hmm. This is actually a bar graph.
Really?
Mm-hmm. This is a bar graph.
Oh, because it's categorical.
It's categorical. I know that the bars are touching, but these are from observed categories. Does that make sense?
Mm-hmm.
So the answer to this guy is A, B, C, or D.
D.
It is D. Okay. It doesn't, and again, it didn't matter if the bars were in order. Like I could have put the 1 right here and the 0 right here, but this is a bar graph. I know that the bars are touching. That's why they made it like this, because they're trying to throw you off. Okay. They really are trying to
already.
say it again.
I am thrown off already.
Yeah. Because the bars touch, usually that signifies a histogram, but these are categorical. Remember, this is coding.
Okay.
1 represents you have a garage. 0 represents you don't have a garage. So that would be the same as if I said no garage, garage here. Okay.
Mm-hmm.
All right. So it actually is D. And B says, how could the graph being improved? So the graph could improve by making the bar graph a pie chart, and the change would make the variable garage be seen as categories and not as numbers. The bar graph could be improved by changing the units on the vertical axis to relative frequencies. Remember, relative frequencies are like percentages. Okay, so that would show proportion. The graph could be improved by containing more categories under garage to show 1 car, 2 car, so on and so forth. The graph could be improved by switching the garage categories. See how everything's down here is about like categories and things like that? That's how I also know it's a bar graph. So this would sort the graph from most frequent to least frequent, changing it to a Perot chart. So what do you think?
A.
Yeah, I would go with A. I heard someone say B. Changing it to relative frequencies is okay. Again, usually when they change the relative frequencies over here, they're the decimal versions of the percentages. So some people could be thrown off by that because they'd be like, oh, this is a decimal. That doesn't make any sense. Does that make you get what I'm saying?
Yeah.
So yeah, I mean, how could this can be improved would be to change it from the bar graph that it is into a pie chart. Okay. That's a way that we could improve this graph. Okay. Because basically, I mean, a Perot chart really doesn't matter. There's only 2 categories. So it's not like it's going to affect anything if I just switch the 2 bars around. So that's why D doesn't make it a good call. And then, you know, having 1 garage, 2 garages, and it depends on what you're after. I mean, this is kind of just junk right here. I mean, when it comes to bar graphs, you don't want to make it too detailed. Okay. So I would definitely say the answer is A. Everyone good?
Mm-hmm.
All right. So right down here, the accompanying pie chart reports the number of hours of sleep last night for 114 college students. What would be a better type of graph for this?
A histogram?
Yeah, I'd probably throw a histogram at this thing. Okay. So it also says select all that are involved, right? So I'd probably throw a histogram because it this is measurable. Does that make sense?
Yes.
This is measurable. So a histogram would definitely be a better display because we use things that are measurable. That means it's numerical. A histogram is going to show this a lot better. And there's one other,
Dot plots.
the dot plot.
Yeah.
Because again, dot plots and histograms, stem plots, they're used with that numerical data. Okay. So the other two, A and B, which these are probably supposed to be C and D, but that's okay. These two that are down here, the Perot chart and the bar chart, those are for categorical. That doesn't make any sense because this is not really categorical information. This is really numerical. All right. So there is another question to this. Why is this pie chart hard to interpret? I mean, this is really truly a mess. I mean, did any of you see this small little sliver of gray right there that represented 10?
Oh,
Maybe you
no.
did, maybe you didn't. So why is that hard to interpret? What do you think?
D?
Say it again.
D?
D, there are so many possible numerical values causing the pie chart to have too many slices. Yeah, definitely. Which makes it difficult to tell which is which, right? How many of you saw that little glade? Well, I mean, it's kind of hard to see your hand
I
raised or
didn't
anything.
see it. Yeah.
Yeah, some of you missed that, right?
Yeah.
That's tough to see. And it kind of blended right in next to another dark color. So definitely D. Okay. You can have large sample size with a pie chart. It just all depends upon how many categories there are. And it should be categories and not numerical. So that's another reason why a pie chart is not the best thing that should have been used here, because this is all numerical data, not categorical. Okay. Colors are too similar. Yes and no. I mean, I can definitely see all the different colors. Even now that I pointed out the gray to you, you can see it all now. So it's not the colors. And right here it says the pie chart shows the proportions. Kind of, sort of, but not really. So D, again, is the better value. Yeah, pie charts are not really good when you have a lot of categories. Try to stay away from that. All right, 15. So it says refer to the accompanying graph, which shows the time spent on a typical day talking on a cell phone for some men and women. Each person was asked to choose from one of 4 intervals, okay, that best fit the amount of time they spent on the phone. All right. So part A, remember, this said that they had to choose from intervals, okay? So it says identify the 2 variables, then state whether they are categorical or numerical. So variable 1, okay? It's either gender or a number of cell phones. Which one is it?
Gender?
Gender.
It is gender, okay? Because the other variable is hours on cell phone, not the number of cell phones. Does that make sense?
Yes.
So make sure that you read some of these carefully because they're going to try and throw some other things at you. So this is definitely gender for the first blank. So the next one says, which is a blank variable?
Categorical?
Definitely. Either you're male or you're female. according to this survey. Okay, definitely categorical variable since it describes blank qualities or quantities.
Qualities.
Quality.
Yeah, qualities. Categorical is all about qualities. Guys are killing this. All right. So it says the other variable is blank. Age of user, type of cell phone, time range.
Time range.
You got it. Here is the $50 million question, which is a blank variable. Is it numerical or is it categorical?
Numerical. Time.
This is categorical.
It's
And
time.
Oh,
And it-
because intervals.
Yes. Because I am giving you intervals, I am now classifying you. Does that make sense, Miriam? I know that it is a measurement. I get that. And if they were allowed to put in their total number of hours,
Mhm.
then I would say it's numerical. But how are they supposed to answer this? In intervals. Are you in the category 0 to 4? Are you in the category 12 or more? Does that make sense, Miriam?
Yeah, I got it now. Yeah, I missed that sentence.
Yeah, they had them answer in intervals, and that's what makes this categorical.
Mm-hmm.
Okay.
That makes sense.
And then again, since it describes qualities or quantities,
Qualities.
it's a quality again. Everyone good on that?
Yes.
Okay. So it says, is the graph a bar chart or histogram? Which would be a better choice for these data?
A bar chart.
It is a bar chart. Absolutely. Because again, remember, these are all categories.
Categories, yeah.
Okay. So our answer then is either B, D, or F. Which one is it?
B.
So B, the graph is a bar chart. It is the better choice since both variables are categorical.
Yeah.
And I agree.
Yeah.
Both variables are categorical. There's no denying that. We just answered that. And bar charts are used for categorical. Okay. Because if you look at the other choices, it says both of them are numerical. Well, we didn't say that. And then it says one is categorical, the other is numerical. Well, we didn't say that either. Okay. So there we go. Ooh, some more questions. So C, if you had the actual number of hours for each person rather than just an interval, what type of graph should you use to display the distribution of the
Histogram.
actual number? Say it again.
Histogram.
Yes. Because once you get the actual number of hours, now we're numerical. Does that make sense?
Yes.
So once we actually get those hours, the histogram would be your better choice. Okay. It also says dot plots. Interesting, because dot plots wouldn't be too bad either. But I would say histogram. And then there's a second question here. It says, since this histograms should be used since the time would be a blank variable now.
Numerical.
That's right. Because we are actually getting their measured number of hours on the phone. Does that make sense?
For question C, we need to choose two. Right?
It says two. No. You choose one. Because you would do two histograms. One female, one male. Although dot plot wouldn't be too bad for that either. So See if this says choose all or nope. I would stick with the histogram. It would be really the best overall. But interesting. I actually want to scroll down. I want to take a look at that real quick. Make sure that they said histogram as well too. Number 15. Yeah. C histogram. Yeah. Okay.
Mhm. It's only one, which was one.
Okay. All right. Although, like I said, a dot plot wouldn't be too bad, but if I had to choose between the two, I'd want to look at the histogram. Okay. So D. It says compare the modes of the two distributions and interpret what you discover. Okay. So what is the mode for males?
0 to 4,
What is the mode for females?
4 to 8.
Okay, so now that we know those, let's answer some questions. The mode for women is what?
4 to 8.
4 to 8. Okay, so there's that first blank. Because blank, so its height is 0%. It's the tallest bar for women. Its height is 100%. It's the shortest bar for women. Which one is it?
The tallest bar.
You got it. Mode wants the tallest bar. Okay.
Yes.
And then it says the mode for men is blank.
0 to 4.
Okay. Because blank, its height is 0%. It's the tallest bar for men. Its height is 100%. It is the shortest bar for men.
Tallest bar.
Yay. Okay. And then last but not least, therefore, the distribution shows that blank talk more.
Women.
Women.
Yep.
We don't need a histogram for this reality.
It is true, right? But, the cool thing about our book is, all the stuff that they throw at us, this is real data. It's not made up data. This
Yeah.
is stuff that they've actually collected and put all together. That's why I really like the stuff that you're getting, because this isn't made up or fake. It's all coming from
Okay.
actual collections. So, all right, 16. So 16, the histogram shows the ages of 25 CEOs listed on a certain website based on the distribution. What is the approximate mean age? So here, this is where we are now starting chapter 3. So 16 starts chapter 3. Because we're going to start talking about the mean age, and we're going to talk about median and all that stuff. All right, so what is the mean age?
D.
56 to 60.
56 to 60, yeah. Because it's that tallest bar again. Because remember, when you're symmetric, your mean, median, and mode are right in the middle.
Mm-hmm.
So definitely D. Moving on. 17. So it says, after the installations of Chief Justice of a certain country, the first 6 Chief Justice were 44, 53, 48, 43, 59, and 56. It says, find and interpret the mean. Okay, so you could actually do this by hand if you want. How do we do this by hand?
Add them all up.
And divide by the number.
You got it. So we'll take 44 plus 53. Sorry, I'm kind of writing some of this stuff down. But do you guys really want to do this by hand?
No.
No, right? We've got StatCrunch. We've got our calculator that can help us do all of this really, really quickly. We just got to put in the numbers. So like you said, if we all add them all up and divide by 6, right here, this will tell you the mean. And again, remember, do you guys remember what variable we use for mean?
Uh, and
The what?
The X with the line.
the
Yeah.
line. Yeah.
We call that X bar. Okay. So I'm not going to run this by hand, just so you know, but let's talk about how we do this in the calculator. So we need to put these numbers into the calculator, the 44, 53, and so on and so forth. We got 6 of them. Where do I go in the calculator to start doing that?
Start.
Stat, yes. Then where?
Enter.
Enter, because we want to edit, right?
Then
And again, don't come up here and hit delete ever, because that will delete that column. If you want to delete anything in this column, you hit clear. But let's put in our numbers. So 44, 53, 48, 43, 59, and 56. There's our 6 numbers, and I know it's 6 because if you scroll right back up, right there it says 6. All right, so I got my numbers in there. Now where do I go?
go to stats again.
Stat again.
Edit left, right side.
Not edit.
No, click on the right.
Okay,
Yeah.
so scroll to the right.
First variation.
Yeah, one variable statistics.
Variable.
Enter, and just keep hitting enter all the way through.
Calculate.
And here it all is. And right there at the top is the
The
mean.
mean.
There you go. And you have lots of other information too. Okay.
Deviation.
Who is this guy right here?
Deviation. Standard deviation.
Yep. Standard deviation. There's the number of totals. Down below, you got your 5 number summary, the minimum, quartile 1, the median, quartile 3, and the max. Now, if we were in StatCrunch, I don't really care what this is called, but we put our numbers, right? 44, 53, 48, 43, 59, and 56. Now where would I go if I want to find the mean in StatCrunch? Stat. Okay, then what?
Summary stats.
Summary stats, then what?
Columns.
Column, because we're looking at a column, right? Select the column and hit compute. Now, I like StatCrunch a bit more because, again, it gives us a lot more information that's more important to us. Again, you can see the total number. There's the mean. There's that standard deviation. Here's the median. This actually gives us the range where the other one did not. And then again, you got your 5 number summary, the median, the min, the max, quartile 1, quartile 3. All right, so now we've got information. So let's go back and let's start answering our question. So it says right here, give us the mean to the nearest 10th. Well, we already know what that is. It's 50.5. Okay.
Yes.
Oh, wait a minute. Hold on. 1, 2, 3, 4, 5, 6. At their installations as Chief Justice of a certain country, the first 6 were this. It says, find and interpret the mean age at installation. Okay. So we know what our mean is, right? Now there's a second question to this. So there's 2 questions to this. So it said, did the first 6 judges, so these are the first 6, did they tend to be older or younger at installation than the most recent 6? So the most recent 6 had a mean age of 52.
62. Yeah. So it's younger.
Sorry, 62. So
Younger.
were the first 6 older or younger?
Younger.
Younger. There we go. So there are 2 questions in that part A. All right, part B says, find the standard deviation. Okay. So we can go look at that. Again, we have our calculator. You already told me that the standard deviation was this one. So, and let's get what they want us to round to. So they say round to the nearest tenth. Okay.
6.5.
6.5. Good. And again, if you were in StatCrunch, that's that information right there. 6.5. Okay. And again, it asks us another question because standard deviation talks to us about variation. So the first 6 had a standard deviation of 6.5. Okay. The most recent 6 Chief Justices was 9.3. So did the first 6 have more or less variation?
Less.
Less. Because their standard deviation number is smaller, that means there is less variation. The larger your standard deviation, the more your data varies. Does that make sense?
Yes.
Or in other words, another way to think about it is the smaller the standard deviation, the more your data is clumped closer together. The larger the standard deviation, the more your data is spread out. Okay? No clumping, but like wide distances between each other. So that's another way to think about it. So part B is less. Okay? But now it asks another question. So it says less than the most recent justices because the standard deviation of the first 6 justices is blank, greater than or less than the standard deviation of the most recent.
Less than.
Less than. You got it. All right. Moving on. Number 18. Okay. So, hey, I think you recognize this one. Now, the problem with this is, Deanna, I'm going to need the information for this. You forgot to include all the long surfers and short surfers for this, for number 18. So technically, I can't do this one. But this is a lot like what we just did a second ago. Okay. So number 18, not applicable right now. I have to come back and record that later on. But this number 18 is just like what we did in 17. Does that make sense? There's a list of numbers for longboard surfers. There's a list of numbers for shortboard surfers. Okay. So you will plug in your data, and I would just do this one at a time. So in stat, in our calculator, I would go to stats, go to edit, and I would put in the longboards first. And you should end at 30. Does that make sense?
Mm-hmm.
And then run your one variable statistics. And when you run that one variable statistics, make sure that you write down the mean and the standard deviation, because that's what they want from the longboards. Follow me so far?
Yes.
Okay. Then you go back in, go into your list, scroll up to the top, hit clear, and then enter. Clear, then enter. Don't hit delete. So, and then put in the shortboards. And then go back to stat, go to calculate, and run your one variable statistics. Write down the mean and the standard deviation. And then you have all the information you need for this. Because you'll have the mean for the longboard, the mean for the shortboard. You'll have the mean for the longboard, or the standard deviation for the longboard, standard deviation for the shortboard. And then you can answer the 2 questions. Okay? The larger the mean, the more surfing. Okay?
Mm-hmm.
So whoever has the largest mean is the answer to this one. Now down here for standard deviation, whoever has the largest standard deviation is the one that is more varied. So they're not asking about the smallest one here. They're asking about who has the largest standard deviation up here. And that will be the one that has, or that will be the one that has the most varied days. You follow me?
Yes.
If you do this in StatCrunch, you could actually do both of these at the same time. Okay? So So you would put all of your information in variable 1, and I would just call it long. Put all the information in variable 2 for short. Let me just make up some information here. So, and then what you would do is you would run stat, summary, columns, pick long, calculate, and there's the long. And then run stat, summary, columns again, pick short, calculate, and then there's the short. And you have the means, and then you have the standard deviations. Okay, does that make sense in StatCrunch?
It seems easier.
Yeah, I'm sorry that I don't have the data. Sometimes things go wonky on us when we're making these in PDFs, and we put it in and it doesn't pop out or things like that. But that's how it's going to work. Okay. So you're basically running the data twice. Do it once for longboard and then once for shortboard. Make sure you get the means and make sure you get the standard deviations. And again, in here, whoever has the longest one whoever has the highest number is the answer to this. And here, whoever has the highest number is the answer to being more varied. Okay? All right, 19, moving on. So here we're getting to that empirical rule. Remember the empirical rule of 68, 95, 99.7, or instead of 99.7, the book said, our book says nearly all. Okay. So in 2011, the mean rate for violent crimes per 100,000 people for 24 particular states was 100 or 411. I think I just had someone say that there's some chatting going on. Oh, we've got data. We've got data. Let me grab this and save this real quick. Let's go to desktop. So hold on. We're going to go back and do number 18 real quick. She's got me some data. And I'm going to run this in StatCrunch instead of on the calculator. Okay? So that way I can get both pieces of information up on the screen at the same time. Okay? Yes. Good. I'm glad you all agree. All right. So go. Stop. Got a lot of things open. Here we go. Data. And it's coming. It's thinking about life. There it is. There's our lovely data. Okay. So, and you guys have access to this picture. We just put it out in the chat if you wanted to open it up. I think everybody had access to it. Let me see what she did with that.
Yes.
Yes, she gave it to everybody. So if you open this up for me, that would be great. So there's our data, and that way I can have you guys read me off the numbers. Because other than that, I'll have to be flipping back and forth. All right, so let's call this long. Let's call this short. Okay. So give me the long data.
7,
Cool.
8, 15, 14, 20, 8, 15. Oh, I'm getting lost. 8.
It's okay. Take your time. Don't rush.
And then 15, 5, 18, 21, 22, 13, 9, 17, a lot of numbers, 19, 12, 13, 9, 16, 14, 13, 14, 22, 12, 6, 14.
6
Yeah,
and then 14. Okay.
17 and 12.
Perfect. You gave me 30 numbers, and that's what I needed. All right. So I need short.
All right. So it's 15, 18, 11, 8, 7, 15, 7, 20, 14, 15. Oh, I'm sorry, not 15, 5. I'm sorry.
It's okay. So 5, no 15. Got it.
13, 4, 14, 17, 9, 10, 11, 18, 7, 18, 6, 19, 4, 17, 14, 14, 16, 4, 14, and 11.
Yay, another set of 30 numbers. And so now all we're going to do is just run our statistics. So summary stats, columns. First, here is the long. And then we'll go back, stats. Sorry, stat, summary statistics, columns. Select short, compute. And now we got our 2 pieces of information. So we now know the means. Okay. So the mean for long, let's see which one wants in our data first. So let's scroll back up. So A, it wants the long. So our mean for long is 13.6. Our mean for short is 12. So based off of that information, who tends to go surfing more?
Longboard.
The longboard. All right, so there's A. 13.6, 12, longboarders. All right, B. Standard deviation, and it says round to 1 decimal place. Okay, so standard deviation for longboard right here. 1 decimal place is what?
4.7.
Perfect. So there's longboard. Short board rounded to 1 decimal place.
4.9.
0.9.
Uh-huh. So now going into blank tend to have more varied days.
The short boards.
The short boards. Because they have the higher standard deviation.
Yeah.
Not by much, but so it goes 4.7, 4.9, and this would be short borders. All right, there we go. Data included, moving on. All right, number 19. So we were talking about this, that the mean rate for violent crimes is 24, or for 24 particular states was 411. The standard deviation is 178. So assume the distribution is unimodal and symmetric. So it says the graph on the right is a sketch of the distribution of crime rates. What percentage of the data should occur within 2 standard deviations? So this is testing your knowledge of that empirical rule. Okay. So remember in the empirical rule that when you're looking at that graph, right in the middle is your 0. And then you have this 1 standard deviation above and below. And how much was in here?
It was like the percentage.
Yes. And it doesn't matter what's going on in that picture. In general, the empirical rule says how much is between 1%.
68.
Or not between 1%, sorry, 1 standard deviation.
68.
68%. And then when we moved out a little bit further, we got to 2 standard deviations? And how much is between 2 standard deviations?
95.
Yes. And then if you went out even further, how much was between 3?
99.
99.7%, or as the book sometimes says, nearly
Oh.
all. Okay? So that's what this is testing you on. So if you look at this, notice this is 1 standard deviation. Okay? Because this is the middle. So that's 68%. How many standard deviations are we from A to C?
99.7. I mean, 95.
95, because this is 2 standard deviations away. Does that make sense? You follow me?
Mm-hmm.
Okay. So we would definitely say 95%. Because you are 2 standard deviations away on that bar. Does that make sense?
Yes.
Okay. They're just testing you on the empirical rule. That's it. So part B, it says, how was the number 598 obtained? What did they do?
They added 1 standard deviation to the mean.
You got it. Because we went 1 standard deviation away, right? Here's the mean. This is X bar. And we went up by 1 standard deviation because this is 1 standard deviation away. So exactly what you said, they added. So which answer is it? A, B, C, or D?
C.
Yay. Moving on. Oh, there's more questions. Sorry, it's not just A and B. So it says, what are the crime rates for areas A, B, and C? Okay. So how do I get the B crime rate? What are we going to do?
Minus 141, like subtract 178.
Yeah. Take 411 and subtract 178. So go to your handy dandy calculator and take 411 minus 178. What do you get for B?
233.
233. Okay. So now we know B. How do we get to A?
You take 233 and you subtract another 178.
You got it. Or you can take 411 and subtract 2 standard deviations, which would be 2 times 178.
Yeah.
Either way. Okay. So what do we get?
55.
Okay. So A is 55. And then how do we get to C?
You add 2 standard deviations.
Yeah. Or again, like what you would say earlier, take the 589 and add 178 to it. Both are correct. But I like to think about it in terms of the standard deviation being multiplied and then added or subtracted on. So what is C then?
767.
Okay. So if we scroll down to this, A is 55, B is 233, C is 767. And again, I wrote this down for you guys. All it is taking your mean and we're either adding or subtracting a certain number of standard deviations. Okay. But we're not done. We still have D, E, and F. So D says, between what 2 values would you have 95%?
Is this
So
where we
now,
have the top?
say it again.
Is this where we have to find the top value? And like,
Well, you actually did. They actually put all those top values down here at the bottom. So these values, I would put them on top, but That's neither here nor there. So they actually put all the values that I would usually put on top like this. Here, I'll show you. So this is the 411. Let me write something down real quick. 589, 767, 233, and 55. So how I usually taught it is I put my numbers on top, but what they did is they just went ahead and put all these numbers down here. So you don't actually have to find the top numbers. You've already did that. Does that make sense?
Yes.
Okay. So they just want to know between which two values is 95%. From where to where?
55. I
Uh,
mean,
50. Uh-huh. And what's the top number?
767.
767. You got it. And there you go. That's what D was after. Okay. Just the empirical rule. That's all it is. E says, between what two values would you find 68%?
233.
233. I heard that. And
500 something. I forgot the number.
589. There you go. That because to be 68%, you're one standard deviation away. Okay. And then last but not least, they want to know, is this unusual? If one of the states had a violent crime rate of 333 crimes per 100,000 people, would this be considered usual? So let's take a look at this. So 333. 333 would fall right in here. So is that unusual?
No.
Usual.
Yeah, that's usual, right? Because it's
yeah.
really close to the mean, right? Does that make sense?
Yeah.
You're not even one standard deviation below it. So that's definitely what we would say is, I would say no. It would not be considered unusual. So we're between A and C here. Let's read. It falls within one standard deviation, or because it is more than two standard deviations. Which one is it, A or C?
A.
A. Because it is less than one standard deviation. It falls within one standard deviation.
Yes.
Does that make sense?
Yes.
Oh, there's a question G on here. The directions say F. That's all right. We'll deal with question G. So question G says, if a state had a violent crime rate of 10 crimes per 100,000 people, is that unusual? So if we go back to my little chart here, 10 would be down here. Is that unusual?
Yes.
Yes. Because you can see that's over two standard deviations away.
Mm-hmm.
So we know that our answer is either now A or B. Which one do you think?
Yes, would be considered because it's one standard. It's one standard deviation. It's more than
BB.
It would be B.
two standard deviation.
Because it is more than two standard deviations from the mean. Does that make sense?
Yes.
Okay. All right. So there we go. There's question number 19. Question number 20. 20. Here we go. In 2007, the mean rate of violent crimes for 10 regions of the northeast of a certain country was 336. The standard deviation was 125. Assume the distribution is unimodal and symmetric. Let's answer some questions. So here is where we want to build that chart, okay? Because it's going to ask us between what two intervals do I have 95%. So in other words, they're making you do all this picture from scratch now, okay?
Mm-hmm.
So we know that the mean, X bar, is 336. We know that the standard deviation is 125. Okay, so let's build our picture together. So in the middle is who?
The mean.
The what?
The mean.
The mean, the X bar. And I'm going to go ahead and just like what I've normally done when I teach class, I put the numbers on top. So 336. Okay. So then over here, this is a standard deviation, one standard deviation above or below. So how do I get this number?
You add
Add what?
125.
125. So what's 336 plus 125?
So it's 400. No. 461.
461. Okay. What would be one standard deviation below?
Minus 125. 336 minus 125.
You got it. Take 336 minus 125.
211.
211.
Mm-hmm.
Okay. And then if we go two standard deviations, so how am I going to get from 461 to here?
Another
You got it. Yeah, add 125. What do we get?
586.
586. And then how do I get from 211 to the two standard deviations?
211 minus 125, 86.
All right. And I think that's enough information. I don't think we have to go beyond that. So
Yes.
let's start answering some questions. So it says, where is 95% of the data going to fall?
The 95 is 95 is what it's one place, right?
Nope.
It's two standard deviation.
It's two standard deviations.
Okay.
90. So where's two standard deviations begin? Below. At
Can
what
you
number?
go to the picture?
Yes, I can. Absolutely. So where are two standard deviations below? Where does that begin?
86.
Yep. And two standard deviations above?
586.
You got it. Boom goes the dynamite.
Okay.
All right. So B says, so again, 86 and 586. So B says, where is 68% of the data?
211.
211. And?
461.
Perfect. Rocking and a rolling.
Oh.
C says, if a northeastern region has a violent crime of 347, is this unusual? So 347 right in here.
Usual.
Is that, yeah, that's usual, right? So let's go back. So we're going to say no. So it's either A or C. Which one is it?
Because it falls within one standard deviation. A.
All right. See how this question is just like what we did a second ago. Except this time we just had to make the picture. It's the same idea. So D says the northeastern region has a violent crime of 58 crimes. Okay. So they want to know, is 58, which is down here, unusual?
Yes.
Unusual.
Yes. Okay. So that is unusual. So it's either B or C.
B.
Yay.
No, that's- yeah.
Guys are killing it. Love it. All right, number 21. So here we're going to start talking about some Z-scores. Okay. So it says the dot plot shows the height of college women, the mean. So X bar is 64 inches. Okay. And it says the standard deviation is 3. Okay. So they want you to find the z-scores and the height based off of the z-score for the given information. Okay. So let's jump in over here. So here's what we know. We have in here a z-score that is 2. And in part A, we want to find a z-score for 64. All right. It's just writing some stuff down for us. So we want to know what is the z-score for 64. And then we want to know what is the height when the z-score was 2. Remember, z-scores are found with this formula. Your data value minus the mean all over the standard deviation. Does that make sense?
Yes.
So this is just plugging and chugging and solving a formula. That's all this guy is. So here, for the first one, we want to find z of 64. So that means we're going to plug in 64, subtract the mean, which is 64, and divide by the standard deviation.
3.
So what is 64 minus 64?
0.
What's 0 divided by 3?
0.
There you go. So your z-score is 0. It was 64, right? Okay, it was, yeah. All right. So our z-score for 64 inches is 0. It's right on the mean. Now this guy, it's going to make us work backwards. We know the answer is 2. We do not know what the data was. The mean is still the same. The standard deviation is still the same. So this one is actually running the formula. This one is working it backwards. Does that make sense?
Yes.
All right. So when we work backwards, how do we solve this? What do we do?
Multiply by 3.
Yeah, multiply both sides by 3. Or in other words, you can think of this as a proportion. That number's over 1, right? And cross multiply. 1 times x minus 64 is x minus 64. 2 times 3 is 6. And then all we got to do is add 64. So x is equal to,
70.
and there's the answer. Our question mark was that the person was 70 inches. Make sense?
Yes.
Okay. So if we're looking back at this guy right here is 0. This is 70. All right. Almost done. Yeah. We only have up to 25. We're on 22. Okay. 22. An IQ test has a mean of 109 and a standard deviation of 15. Okay. So we got an X bar of 109 and a standard deviation of 15, writing that down. So it wants to know which one is more unusual, an IQ of 79 or an IQ of 140.
144.
Or 144. Yeah, thank you for the correction.
The answer is 144, right?
Oh, are you sure?
And IQ test has a mean 109.
Well, how can we tell if two scores, or what can we do with these two scores to see if they are, to know which one is the most unusual?
Solve for
The-
this.
Subtract the.
Find their z-scores. Whoever has the higher z-score, that means you are further away from the mean. That's unusual. Does that make sense? Because z-scores are all about how far are you from the mean. The lower your z-score, the more you are going to be closer to the mean, the less unusual you are. Does that make sense? You follow me on that?
Yes.
The higher the z-score, the further you are away from the mean. So if we find the z-score, whoever has the highest, you're the more unusual. So z-score, we'll take 79 minus 109 and divide that by 15. And over here, we'll take 144 minus 109 and divide by 15. So you just do some calculator work. What's 79 minus 109 divided by 15?
-2.
-2. Okay. And then over here, what's 144 minus 109 divided by 15?
2.3 repeating.
2.3 repeating.
Yeah.
So who is the furthest away from the mean?
79.
Who's the furthest away from the mean?
Z-score of 79.
Mm-mm.
44.
The
144.
144. This number is 2.3 away from the mean. This number is just 2 away from the mean. It's negative because it's below the mean. Does that make sense?
Yes.
So this is the biggest number overall. So that means this guy is the more unusual. So we would select B as our answer. And filling in the blank, we would say it is more unusual because its corresponding z-score is blank. What is the z-score? 2.3 repeating. And it says round to 2 decimal places. So we would actually say 2.33 is further from 0 than the corresponding z-score of blank.
-2.
-2. And since it says two decimals, I would actually put 0.00 just to appease it. Even though I do not believe it will count you wrong if you just put -2, but since it asks for 2 decimal places, and normally when we look at z-scores, which you will find out soon enough, we generally look at it as 2 decimal places. Okay?
Mm-hmm.
So we would select B, you would put 2.33 and -2.00. And there you go. 23. So it says assume women's height have a mean of 62 inches and a standard deviation of 2. Find the following information. What is the woman's height according to these scores? And it says do not round on these. Okay. So we've got a standard deviation, a mean of 62, a standard deviation of 2, and we are doing 2 things. We want to know what is their original height. So we've done this before. We did this back on number 21. So what's the height of someone that has a z-score of 1.70? And what is the height of someone that has a z-score of -1.10? So all, again, they're asking you to do is work backwards on this. That's it. So 1.70 is equal to our data value minus the mean, 62, divided by 2. And then down here on this one, it's -1.10 equal to whatever our data value is, minus the mean, divided by 2. So if we cross multiply, what is 1.7 times 2?
3.4.
And that's equal to our data value minus 62. So if we add 62 to both sides, what's our answer for A?
65.4.
So 65.4 inches. And then over here, what is -1.1 times 2?
-2.2.
Uh-huh. And then all we're going to do is add 62 to the other side. And what do we get?
Uh, at 62, you mean?
You're going to add 62 to both sides.
59.8.
Okay.
And
There you go.
62 plus 62.
So 59.8 inches is the other woman. Everyone okay on that?
Yes.
Okay, so and that's why they didn't want you to round, because it's already good to go. So in this first box, 65.4, and the second box, 59.8. Okay, 24. It says select all that apply. So it says name two measures of variation and state the conditions under which each measure is preferred. So is a z-score a measure of variation?
Yeah, I got this.
Is a z-score a measure of variation?
No.
No. Is standard deviation a measure of is standard deviation a measure of variation?
Yes.
Yes. So, but the question is this the correct condition? We use standard deviation when we have lots of points.
No.
No. So, but there is another standard deviation. It's right down here, G. Standard deviation is preferred when the data is symmetric. Is that true?
Yes.
Yes. So you would select G. Okay. Now let's keep going. Is median a measure of variability?
No.
Is that a yes or no?
No.
No. So no median. What about interquartile range? Is that a measure of variability?
Yes.
Yes. And is this correct? We use it when we have skewed data.
Yes.
Yes. So D and G so far, let's double check one last piece because they give us one more here. Is mean a measure of variation?
No.
No. So the final answer is D and G on this. Interquartile range and standard deviations are the only two measures of variations. And we use standard deviation for symmetric, and we use interquartile range for skewed. Plain and simple. Last one, we did it. We made it. Number 25, and it's 2 parts. Glorious. All right. So number 25, part A. In your own words, well, obviously not your own words because they're providing us multiple choice here. Describe to someone who knows little about statistics how to recognize when an observation is an outlier and what actions should be taken with an outlier. So you got 4 choices here. Tell me which one it is.
D.
It is D. Okay. So the first thing is, yes, outliers are observations that are more than 1.5 from the interquartile ranges. But also, I mean, the big thing is that outliers, they are observed values far from the main group. In a histogram, they are separated by spaces. Okay. Outliers must be looked at in closer context to know how to treat them. If they are mistakes, they should be corrected or removed. If they are not mistakes, you might want to do the analysis twice. That's the big thing right here. Because if you look at B, yes, this is true, all of it. You should look at them in a closer context. But the big thing is, I mean, it says sometimes they may be included, sometimes they may be discarded. Well, that's good, but I mean, there's really more to it. And D is really the best answer. Okay, although B is pretty close to it. I like B a lot because it actually tells us how we can kind of find outliers, but this is the big part. The reason why B is not the answer, because you're talking to someone who knows little about statistics. That means this person doesn't know about interquartile ranges. They have no clue. They don't know what a median is. Okay, it's a little bit easier to explain a histogram, like, you know, it looks like a bar chart with spaces. Okay, this is all more for someone who does not understand statistics. Okay, does that make sense on those? Kind of
Yes.
talking about this, because yes, B is a pretty close choice, but this is for someone who really does know about interquartile range and medians and things like that. This is more for someone who doesn't know, and that's the key, who knows little about statistics. And then part B, it says choose the best answer below. Okay, so it's just asking you some questions about the median or mean. Who is more resistant?
Median.
Okay, the median is more resistant to outliers. That's what all this is about, is outliers. Okay, who's more resistant? The median. So it's either A or B. Which one is it?
B.
B. So the median is more resistant, which indicates that neither the number nor the magnitude of the outlier has any effect on it.
Yes.
Okay. So the answer is B. Okay. That's what it's down here. Because remember, outliers really do affect the mean a lot. The outliers pull the mean either towards a higher value or a lower value, depending on how big or how low the outlier is. So we know it's not these. The mean is not resistant. And that right there is it. That's what exam 1 will be like. Basically, all that's going to happen is I might change the graphs, I might change the numbers in the questions, but I mean that's really it. These problems look just like the homework problems you had. They're just like the problems that you're going to see in the quiz. You guys got this. Cool beans?
Yes.
All right. And that's it. I'm done.